All right, so continuing on 4.1, we're at arc length formula. And so we know that our arc length is equal to our radius times our angle. And remember we talked about in class that our angle, though, has to be in radians. Anytime we do word problems, our angle is going to have to be in radian measure. All right, so on example 6, it says a circle has a radius of 18 inches. Find the length of the arc intercepted by the central angle whose measure is 210 degrees. Excuse me. So, what do we know? Well, we know our radius is 18. And we know our angle is 210 degrees. And we're after the arc length because it wants to know the length of the arc. So, we also know that our theta, though, has to be in, no equal sign. It has to be in radian measure. So, we're going to multiply by that pi over 180. So 210 pi over 180, and we're going to reduce 210 over 180, which is 7 pi over 6. So from there, we can go ahead and work out our problem. We're after arc length. So remember, arc length is equal to the radius times theta. So it's equal to 18 times 7 pi over 6. And let's go ahead and put your pi in your calculator as well. And so we'll find the arc length is 65.973 inches. All right, so moving on to example 7, finding the distance between cities. Excuse me, it says we obtain the latitude of a location L anywhere on Earth by first finding the point of intersection P between the meridian through L and the equator. The latitude of L is the angle formed by rays drawn from the center of the Earth to points L and P, with the ray through P being the initial ray. So, I'll just help you get that set up. So let's just keep going. So it says Billings, Montana is due north of Grand Junction, Colorado. Find the distance between Billings, which has a latitude of 48 degrees 48 minutes north, and Grand Junction, whose latitude is 39 degrees 7 minutes north. Use 3,960 miles as a radius of Earth. So because Billings is due north of Grand Junction, the same meridian passes through both cities. The distance between cities is the length of the arc S on the meridian subtended by the central angle theta, that is the difference in their latitudes. So what we have here then is, let me turn my pen on. All right, so we've got, let's let this line here be our equator. All right, and so they gave us the two cities, and so if you look at the angles, Grand Junction is closer to the equator because its angle is smaller. And so that means that the angle from here to here is going to be that 39 degrees 7 minutes. Well, I need that in decimal degrees, so we're going to take that 39 degrees and we're going to add 7 minutes. Remember, we said take degrees like an hour. There's 60, so 7 over 60. And so we can put that in our calculator, and we get approximately 39.117 degrees. Then we also have, what was our other city? Billings. All right, so then here, north of Grand Junction, we have Billings. And it told us that its angle, so from the equator to that line there, was 45 degrees. I'm going to write this on the outside actually. So we know that that angle is 45 degrees. I'll get it right in just a minute, sorry. And 48 minutes, which means we need to change that to decimal degrees. So 45 degrees plus 48 minutes out of 60 total, which is, when you put that in your calculator, you should get 45.80 degrees. Okay, so now we know our angles. But remember, now we're looking for the distance between these two cities. So we're looking for the arc length right there. And so we know that our arc length is equal to the radius times theta, Well, we know our radius because it tells us up there, use 3,960 miles as the radius of Earth. So the equator part right here, the part we're looking at, it's a 3,960. So there's our radius times our angle. Well, we're only after the arc length between Billings and Grand Junction, so I only need that little angle right there. And so I can find that angle by subtracting the other two. So my angle that I'm looking for is going to be the 45.80 degrees minus the 39.117 degrees. And so when I subtract them, I end up with 6.683 degrees. But remember, when you're doing a word problem, it's got to be in radians. So I'm going to multiply that by pi over 180. And okay, so sorry about that. So when I multiply these, I'm just going to put the whole thing in my calculator because, well, this is a word problem in the end. I'm going to end up putting the pi in my calculator anyways. And so I get that this is approximately 0.117. So that's my angle. So I'm going to put in 0.117. And then I multiply that by the 3960. Now using the rounded values there, using that 0.117, you'll get 463.32, and it's measured in miles. So your answer should be around that amount. If you use the exact, it may be a little bit bigger, a little smaller. I'm not real sure right offhand, but it'll be one of those. It'll be close though. All right, so let's talk about area of a sector. So the area A of a sector of a circle of radius r formed by a central angle with radian measure theta is. So we're just looking for the area of a piece of that circle. So it's going to be our area is equal to 1/2 r squared theta. So how many square inches of pizza have you eaten, rounded to the nearest square inch, if you eat a sector of an 18-inch diameter pizza whose edges form a central angle of 30 degrees? So we're after how many square inches? Square inches, that's an area. So the area is equal to 1/2 r squared theta. Well, we're after A, and so do we know the radius? Well, our radius is going to be 9 because it says it's an 18-inch diameter, and remember, radius is half of the diameter. And I need my angle. Well, it told me my central angle was 30 degrees, but again, this is an application or word problem, so we got to convert it to radians. And so when you do 30 degrees times a pi over 180, we get pi over 6. So I know my area is equal to 1/2 times 9 squared times pi over 6. I'm going to plug this into my calculator. And so I get approximately 21.206, but it says rounded to the nearest square inch. So our area then is going to be 21 square inches. All right, and moving on. So we're going to talk about linear and angular speed. Suppose an object travels around a circle of radius r. If the object travels through an angle of theta radians and an arc length of s in time t, then the linear speed is going to be v is equal to your arc length divided by time. Your angular speed, which is represented by that funny looking w, that's called omega. It's a Greek letter, so omega is equal to your angle divided by time. Further though, since we know that s is equal to the radius times theta, we can come up with a formula, which is the number 3 down there at the bottom, that says the linear velocity is equal to the radius times the angular velocity. Now, some things to note is that when you're doing linear speed or linear velocity, your angles always, you're going to have an arc length here. So it's going to have length as a measurement. All right, so it might be feet per minute, miles per hour, something like that. That's linear speed or linear velocity. Angular speed or angular velocity will always have some type of a angle measurement on top. So it might be radians per second or revolutions per minute or degrees per hour, something like that. All right, so watch out for those things to help you on the word problems to get you through which one goes with what. All right, so example 9. So it says a model plane is attached to a swivel so that it flies a circular path at the end of a 12-foot wire at the rate of 15 revolutions per minute. Find the angular speed and the linear speed of the plane. All right, so we know it's on a 12-foot wire, so that's going to be our radius. So I'm going to write this here, and then I'm going to have to go to a blank page so I can actually do some work. And it goes 15 revolutions per minute. Well, that has to do with my angle. So it's going 15 revolutions. Well, a revolution is a complete circle. So we're going to say that that's 2 pi. Instead of 360, I'm using 2 pi because this is a word problem, and we know where our angle is going to have to be in radians anyways. Might as well just go ahead and go there. So that means that my angle is going to be 30 pi. So I'm going to rewrite that on the next slide here. So we know that our radius we said was 12. And we know that our angle is 30 pi. All right, so find the angular speed and the linear speed. Well, angular speed is the omega. Let me label this. Is omega equals theta over t. And so my theta was 30 pi. My time is 1 because it's per minute, revolutions per minute, which means that it's going to be 30 pi, and its label will be radians per minute. Now for my linear speed, sorry about that thing still being in the middle of my screen there. All right, so for linear speed, since we know omega, we can use the formula that the linear speed is equal to the radius times omega, which means then you're going to have your radius. I'm just going to write this below it. Now I'll write it beside it. So our radius, which is 12, times omega, which was 30 pi radians per minute. So when we plug this in, we end up getting 1130.973, and it's measured, it's a linear speed, so it's got to be in feet from the 12 feet, and the units for the time was in minutes. Alright guys, so that wraps up 4.1. So hopefully you'll watch this and go ahead and be able to knock that out. I'll answer some questions on it first thing in class on Monday, and then we're going to keep going because your 4.2 is now due on Tuesday. So remember, I'm available if you need help. Just let me know.